minus 1, right? This is x plus y, this is x plus y minus z, okay, not plus z, this is x plus y minus z. You can see the first coordinate is x plus y minus z, so that's why this is the coefficient of x, y, z from the first equation, 1 1 minus 1, and then x minus 2y plus z, so we get 1 minus 2 1, and then minus 2x minus 2y plus 2z, you will get minus 2 minus 2 2. Now when you multiply first row with minus 1 and add into the second row, and when you multiply first row with 2 and add into the third row, 1 1 minus 1, so 1 minus 1 0, minus 2 minus 1 minus 3, and 1 plus 1 2, okay. Also when you multiply first row with 2 and add into the third row, you will get 0 0 0, okay. So you can see the following matrix is in row echelon form, right? This is our leading entry, below that leading entry we have 0, and second row this is our leading entry, below that leading entry we have 0, and the third row is already 0. So 0 row is definitely is in the bottom of the matrix. So this matrix is in row echelon form matrix. In this row echelon form matrix, we get x plus y minus z is equal to 0, and then minus 3y plus 2z is equal to 0. So let z is equal to k, okay, because in which column we don't have any leading entry. You can see first column we have leading entry, second column we have leading entry, this is our leading entry. The third column we don't have any leading entry, so that's why the third column is for z, so and that's why we are taking z is equal to k. Now when you take z is equal to k, y is equal to 2 by 3 into k, put the value of z and y in the first equation, you will get x is equal to z minus y. What is z? K minus y, that is 2 by 3k, so k minus 2k by 3, we will get 3k minus 2k divided by 3, so k by 3, so that's why x is equal to k by 3. So this x, y, z, when we write down in a set theoretically, this is the kernel of T. The basis for null space is V is equal to k by 3, 2k by 3, k, and kernel of T is equal to k, 1 by 3, 2 by 3, 1, where k belongs to R. Now to find range of T, so A transpose is equal to 1 1 minus 2. Now how we find range of T? There is one important theorem that from the matrix, from the standard matrix for linear transformation T, the null space of the standard matrix, that is exactly the kernel of T, and the column space of the standard matrix, that is exactly the range of T. But instead of column space of the transformation, we can also find the row space of the transpose of that standard matrix. So that is it's quite easy. So that's why we are transpose the given standard matrix, and then now our target is to find the row space of this matrix, okay, and that is exactly the row space of this matrix is exactly the range of the transformation T, okay. Otherwise you can find the column space of the standard matrix or row space of the transpose of the standard matrix, okay. So that's why here is our A transpose. You can see we are transposing the given matrix A. This is our matrix A. So 1 1 minus 1, 1 minus 2 1, minus 2 minus 2 2, 1 1 minus 1, 1 minus 2 1, minus 2 minus 2 2, right? We are transposing that matrix. Now again we have to convert this matrix into a row echelon form matrix. So the first row is as it is. We are multiplying first row with minus 1 and add into the second row. So the second row is 0, 1 minus 1 0, minus 2 minus 1 minus 3, minus 2 plus 2 0. Also we are multiplying second row with first row with 1 and add into the third row. So the third row becomes 0, 2, 0. Okay. Now next process, 1, 1 minus 2. We are multiplying second row with 2 by 3 and add into the third row. You can see this second and third row are both are linearly dependent now. Okay, because 0 minus 3 0, 0 2 0. Now when you multiplying 2 by 3 of second row and add into the third row become 0 row. Okay, the third row become 0 row. So 1 1 minus 2, 0 minus 3 0, 0 0 0. Now the row space of this matrix, that is the non-zero row vector, the basis of the row space of this matrix, that is exactly the non-zero row vector. So the bases are 1 1 minus 2 and 0 minus 3 0, and that is exactly our range of T. 1 1 minus 2, said theoretically if you want to write A into 1 1 minus 2 plus B into 0 minus 3 0, where AB belongs to R, and hence the basis of range of T is 1 1 minus 2 and 0 minus 3 0. So this question was complete. Now next question, let's see. Question 7a, first part, find the derivative of f of xy, that is equal to x e raised to y plus cos of xy at the point 2 0 in the direction of A is equal to 3i minus 4j. This question was asked in 2 marks. F of xy is equal to x e raised to y plus cos of xy del f by del x. So here we are taking a partial derivative of f with respect to x. So y is a constant, e raised to y, the derivative of x is 1, e raised to y minus the derivative of cos is minus sine, so that's why minus sine xy, and then derivative of xy with respect to x we get minus, we get y. Put the 2 0 in this equation, we get e raised to 0 minus 0, so we get 1. Similarly we can find del f by del y, x e raised to y minus x sine xy, put 2 0 in this equation, del f by del y. So 2 e raised to 0 minus 2 into 0, that is equal to 2. So this is the derivative, directional derivative at point 2 0, that is I del f by del x plus j del f by del y. Put the value of del f by del x, that is 1, and put the value of del f by del y at 2 0, that is 2. So finally we get I into 1 plus j into 2, so I plus 2j. Okay, this is quite simple question, was asked in 2 marks in this question paper. So we solve this question paper up to this question, question 7a. Thank you, have a nice day.